Hello and welcome everyone in here in the Zoom call and out there in the live stream. My name is Marius Bartmann and I'm a research associate at the German Reference Center for Ethics in the Life Sciences here in Bonn, focusing on the ethics of climate change. I'm happy to be back as your moderator for this afternoon session, and we continue with paper session 6 on evaluating AI for sustainability and the sustainability of AI. We can look forward to an afternoon with great talks and exciting panel discussion organized by the World Economic Forum Global Future Council on AI for Humanity on the topic of intergenerational justice, sustainability, and AI. And to top it off, an art installation trailer. A quick reminder for the speakers. You have 20 minutes for your presentation, 10 minutes for Q&A, and I'll signal you after 18 minutes or so. So let's get right to it. It's now my pleasure to welcome our first speaker in this section, Roel Dobbe from the Delft University of Technology. You can dive right in, but please feel free to say a word or two about yourself. The floor is yours.
Thank you, Marius. It's a pleasure to be here. I just came back from vacation. I'm still very much in the midst of getting started again, but it's a wonderful occasion to share some recent work. So my name is Roel Dobbe. I'm with the Delft University of Technology in the Faculty for Technology Policy Management, where I started last year. And today I'll be sharing some kind of initial preliminary insights from an ongoing study on what it takes to do AI systems, energy, and carbon accounting. Mm-hmm. And so I've been working with a master's student, Frank Kloosterman, who recently graduated with flying colors, and I'll be mostly sharing insights from his study. But to introduce like kind of those insights, I will share some motivation. So how can I go to how can I control the slide? Are the slides already shared, or?
I think you have the clicker with which you can control the slides.
Okay. Oh, I'm not in the clicker tool. Anyway, okay. I will just flag it. I've kind of missed that in the communication. The clicker tool is something.
All right, then just signal the tech crew. They will guide you through your presentation.
Okay, so a motivating study for this particular project was I did in 2019 when I was still part of the AI Now Institute as a postdoc, and there eventually I wrote a piece here shown called AI and Climate Change: How They're Connected and What We Can Do About It. That was on one hand exploring kind of the challenges around like how AI systems themselves can contribute to climate change, not in terms of carbon, but also in terms of carbon emissions and in terms of more broader like environmental impacts. And that culminated in a couple of issues. So I've included a QR code here to the piece, which I think might be nice for those of you joining the conference to read, and it has a couple of particular issues that we dived into and some policy recommendations. So on the next slide, those issues they really inform this study as well. So we looked more broadly into the climate cost of global computation. There have been some really good studies more recently that have tried to make sense of a pretty scattered like literature body, but there's not enough information yet to really understand with more certainty what the trajectory is of global computation, but it's on an exponential trajectory. We also started seeing back then that AI systems themselves are, when we look at them, the largest systems are on an exponential trajectory when it comes to the reliance on compute. We saw that also when we look at AI as an industry, there are a lot of problematizing relationships and interactions with the fossil fuel industry. So there's more of a political context that we sketched there. And then the most important point from that piece was kind of the overall opacity and also sometimes obfuscation of in terms of the ability for users of cloud computing services and more broadly computational services to have an insight into what do these services actually cost in terms of energy and carbon efficiency, carbon emissions, and what other kind of environmental impacts, like what's the life cycle, and a more comprehensive kind of insight into what this burgeoning computational infrastructure is actually doing with our environment. And so from there, we had some policy recommendations. I won't go. I have them here on a slide, on the next slide. So I won't go through them now. I'll just show them here. But the first point, mandate transparency, basically says that, like, yeah, if we if no organization really has like a good insight into, let's say, their digital footprint, like what can we really do for, I'd say, particular AI systems. So in some sense, I was already kind of primed to be a little bit skeptical or ready to be disappointed, but I still wanted to take kind of a constructive standpoint and say, okay, let's try to do energy accounting first. So not carbon accounting, but let's just look at energy first. So on the next slide, yeah, the question that I rose, like, oh yeah, there's some more context here. Back then I was working with Kate Crawford, who at that point was also doing a lot of work trying to understand kind of the global value chain of AI systems and the different ways in which artificial intelligence systems are not necessarily artificial. They rely on human labor in all kinds of forms along this value chain, but also they rely on global extraction networks in terms of resource mining and other kinds of materials that are being used for this broader infrastructure. And so to get back to that question that I started asking on the next slide, I thought, well, looking at the kind of state-of-the-art energy accounting approaches, it should not be a complex problem, right? That was kind of the question. Of course, I knew already a bit that it wasn't really going to be about the technicalities of accounting itself, but really about what's possible in practice. And so here you see a simple formula that shows that the total energy that is consumed for, say, a particular software execution, in this case, say training an AI system, AI model, would be what's called the power usage effectiveness. Has to do with the energy effectiveness and efficiency of, let's say, a data center times. So that's a factor times the time it's running for that particular task, times the power that relates to different computing units like GPUs, CPUs, and memory, other computing units. And the TLDR of this talk unfortunately is not, so that's on the next slide. There's a little thing there. It's not, unfortunately, it is a complex problem, but it's not necessarily a technical problem, which is what we'll see. So in the rest of the talk, and it's not going to be very long, so hopefully there will be plenty of time for discussion and questions. I'll be showing what Frank mostly, what he found out during his thesis research, looking at his question, his approach, some results, and quick conclusions. So the question of his master's thesis was the following, on the next slide. So what are the restrictions on accounting the energy consumption of building, training, and maintaining deep learning models in data centers? So on the next couple slides, we'll just show that we've made his study a little bit more specific. So we look specifically at applications that relied on deep learning. So on the next slide, there's just a couple of things about deep learning. I won't really go into detail, I think, but just for the sake of specificity and being able for him also as a master's student who is both anchored in engineering as well as in policy to be able to have some focus. He looked at different computer vision and text analysis applications that relied on different forms of deep learning. Then we also wanted to have a kind of a comprehensive sense of the life cycle of a model itself. So on the next slide, we highlight that. So we looked at building, training, and maintaining deep learning models, not just building them, but also how do you use them and what does it mean for energy consumption when you, for instance, are collecting new data, or if the system needs to be updated for one reason or another. So in the next slide, we also kind of indicate that with a couple of details, but I think it's straightforward. So let's move on. The last piece of the specificity in the research question on the next slide is that we looked at application, context of application and development where there was a reliance on data centers. And I'll talk a little bit more about that in a second. So moving on, so in terms of training centers, that would give us at least, it started to give us, like if we start from the picture of the developer, we would start to also look at other stakeholders, like the reliance on the data center and the parties involved in delivering services from the data, so cloud companies delivering services through data centers, and potentially also looking at the energy providers of those data centers. Moving on to the research approach, we addressed this question on the next slide. We addressed this question, one further. So we addressed this question through case study research. It's a bottom-up approach. So my exploratory study that I started off with was more of an overview study. Personally, I have been building AI-type systems. I have a background in systems and control theory, but a lot of that was always on my own laptop. So personally, actually, I didn't have much experience working with cloud computing services for training these systems, apart from a few short stints as an intern during my PhD. And so what we did here is try to see, apart taking that overview study as a motivation, like what does it actually mean for people who are building systems to get a sense of the energy consumption of training these systems, and as I said, building, using, developing, and using them. So these case studies were, so they all, the idea was to understand computational dependencies, and they were all in kind of different application domains. And also important to note, Frank worked together with Deloitte, so he was hosted by Deloitte in their IT and IT strategy department, where they had different teams helping their clients with building these kinds of applications. So that gave him access to kind of a variety of case studies. So we started sort of naively saying, okay, can we actually do energy system accounting? That happened to be pretty challenging for various reasons that we'll see, and that's when we switched to actually trying to research the restrictions to doing energy system accounting. And we did that through doing interviews with different stakeholders across the teams that were involved in these particular applications. So developers, managers, and other people that we could get a hold of. So it was very much like an initial study. So it was an multi-actor interview setting where eventually he used coding techniques to start analyzing what are the kinds of restrictions that these people see themselves or experience themselves. And it was also slightly theoretically informed by his own literature research and some probing questions that came out of that. So and then when we got those interviews in and he started coding, restrictions came up in a bottom-up sense, and then he did expert interviews with experts from different public, private, different scientists relevant with relevant disciplines to validate these findings. And he also found some additional restrictions through those interviews. So on the next slide, we see the kind of categories where he found restrictions. Mostly there are other ones, but these were the ones like in the context of developing a system in an organization where you have developers, managers, you have potentially a client and a consultant or developer. That's where you typically find organizational, social, and technical restrictions, as we saw. So organizational restrictions are those caused by organizational structures or a lack thereof. Social is a combination, a category that we define as caused by social interactions or a lack of social interactions, or a lack of knowledge of the stakeholders. So knowledge is also kind of for purpose of presentation and analysis is included here. And then the technical part is caused by the technical characteristics of AI systems and deep learning models. So the actual practice of developing these systems mostly as developers have to do. So now I will go over the restrictions that we found. So 2 minutes. Okay, I will quickly show them. So please go to the next slide. And here you can see them. I don't see the next slide yet. Oh, there they are. Complexity of deep learning, which is technical and social in nature. The innovative stage, lack of incentive to determine the energy consumption, lack of modelers' energy accounting knowledge. And the next slide. A lack of societal awareness, a lack of systematic evaluation of models, long and diverse training times, and the lack of details about the actual hardware to understand what are actually the systems that are running in real time. Okay, so I had a couple extra slides with some example quotes. I will skip those for the purpose of time. Maybe I'll show one. So here's just one that shows complexity of deep learning with the example quote. It's actually all still quite new and the models are not always well understood. This was really a really important insight, is that many of the developers are actually still trying, like as they're building the systems, they're learning what they're doing and what it really means to evaluate a system for the purpose of the actual application, let alone like thinking about other things like energy consumption. And so there are a couple more quotes here that let's skip the next couple slides and go to the conclusion. So this slide maybe is interesting just to quickly just show that if we look across these different restrictions and we've mapped them across these categories kind of in a table matrix style, we see that the organizational and social aspects are more dominant than the technical ones, at least from the context that we did research in. Okay, so then the conclusion. Yeah, you can go to the next slide. This is the research question again. But yeah, so what we did is we gave more of a bottom-up perspective of what AI systems and energy accounting looks like in practice at the moment. This complements a more technical and specialized perspective. There's a lot of technical researchers or researchers more broadly thinking about how to do this, but what does it mean to do it in practice? And seemingly simple accounting techniques are hard or impossible to implement. And we found restrictions caused mostly by organizational and social causes. And this, I think, has great potential for policy efforts to take away such restrictions or to help build the capabilities we need to do a better job at really understanding how to evaluate AI systems and their models, and how to account for energy and carbon emissions and other environmental implications. So I'll stop here, and thank you for your attention, and I'm happy to answer your questions.
Okay, thank you very much for your contribution. I think before we write to like policy recommendations, I think it would be good to take a step back and focus a little on just quickly on the technical side. So you talked about the complexity of energy accounting, and I was wondering, are there like substantial feasibility constraints on doing that? So because you talked about different categories, organizational, technical, social. But I was wondering, is like the mere accounting of the energy, like just computing it, is that already a substantial obstacle, or would that be quite easy to do?
Well, it is definitely. I wouldn't do it justice if I say like it's all about organizational and social aspects, and it should be simple, right? But I started off with that frame because I think it could be relatively simple, a lot simpler if we have more information. But the technical, yeah, we did also look at a literature review of these different methodologies of computing or either measuring or predicting or estimating energy, and it's not straightforward. And you can imagine that these systems, the servers and the data centers more broadly, they serve so many different tasks, and it is hard to kind of link individual electrons to like all the different tasks and activities that go through these data centers. So there are particular kind of assumptions that have to be made for the kind of methods that are out there now. I think those are reasonable assumptions, but they probably don't add up to 100%. But we haven't really found, or we haven't done that kind of detailed analysis into like what does it actually take, how difficult is it actually? And I think if we would have a more open infrastructure, that would be a lot easier to do, of course.
Okay, then if that's the technical aspect of the restrictions, then could you elaborate a little bit on the organizational and social aspect? So you mentioned a few lack of incentives to do it, but can you weigh these? Can you say, well, what are there some features, some obstacles that are bigger than others? Could you say a bit about more? Could you say a bit more about that?
Yeah, I will. So now I'm also leaning on the thesis and on my conversations with Frank. Frank would be in a better position to, because he also said we should try to figure out how to prioritize these different restrictions. And I think I'll lean a little bit more on my like what I've heard and my intuition here, because I think a lot of the results here are kind of they form a stronger hypotheses for further research. But I think, I already mentioned it, that the lack of knowledge, AI system development, it's experimentation with these systems and developing applications is done so broadly at such a rapid pace, and we are still building kind of workforce and like skills and people who could build these systems, and oftentimes, they're learning as they're doing. And I think that's probably, that's a really tough problem because, but I think, that's, of course, also has an impact. And the other thing is that the technology itself is, oftentimes referred to as a black box, but we're still, even though it looks like a general purpose technology, you need a lot of both domain knowledge and actually technical expertise for particular kinds of AI functionality, whether it's computer vision and even within or something else, or even within computer vision, what kind of computer vision systems are you building and what kind of, let's say, deep learning architectures would you need? And you see in all these different case studies, we saw that people were still struggling to figure out, like, should I even use deep learning, or maybe should I just like use a simpler model class or something that's not even that's even simpler than using a model, doing something with rule base, for instance. So that's, I think, where we are with this phenomena called AI systems, so broadly applied, and that of course has consequences also for how much time, and there's other factors here. Not enough incentives and not enough interest in like the cost savings you could get, probably because we saw that for the applications that we looked at, that the overall energy consumption, it's significant, but it's not economically probably not always as significant for the developers or for those investing in these technologies to really care about them. So I think those two things, like knowledge and economic incentives, are probably the most challenging aspects. But again, I'm leaning on also what I took away from the conversations with Frank, and we need further research to see if that's really the case.
Okay, there is one last question, but I think it might be too late for that. So we need to move on to the next speaker, but I hope we can pick up on one facet or the other of what you said, maybe in the next discussion or in other discussion rounds. Topics are related, so maybe we can weave some aspects of this into other Q&A sections and take them up as we go along. Thank you again for your talk. So schedule is tightly packed, so I move on right away to our next speaker. I'm pleased to introduce to you Roel Schwartz. He's from the Hebrew University of Jerusalem and will give the next talk. And in order not to steal you any more time, please go right ahead. But also, again, feel free to say a word or two about yourself, about your work.
Thank you. Can you hear me well?
Yes.
So, hi everyone. Thank you so much for inviting me. I'm very excited to be here. My name is Roel Schwartz. I'm a senior lecturer, which is basically an assistant professor at the Hebrew University of Jerusalem in computer science department. My main field of research is natural language processing, which is a subfield of AI. And today I'm going to be talking to you about green AI. I'll explain a bit what we mean by that. Okay, so when we think about AI today, we're seeing tremendous progress over the past few years. We have machines that can translate text between different languages with very high accuracy. We have machines that we can communicate with and ask them to do stuff for us. We have machines that can beat world champions in games like chess or Go. And we have machines that are able to detect objects or faces and images with very, very high accuracy. And of course, even when you consider the current, hopefully soon to be a previous challenge, but still hanging in there of COVID-19, that humanity is facing, we're seeing AI at the front helping scientists find both cures and vaccines for this pandemic, and also helping other scientists find a way through the huge amounts of data that has been collected about COVID-19. So really, AI is really at the front. It's really hard to miss it. But one trend that somewhat perhaps goes unnoticed is that this success is accompanied by another factor, that AI models are becoming bigger and bigger and more expensive. So here we can see an illustration that shows the state-of-the-art models in AI over the past few years. And we see an exponential growth of 300,000 times in about 6 years between 2012 and 2018. And of course, this trend has not stopped in the past few years. And really, models are becoming more and more expensive, requiring more and more computation. And so in this talk, I'm going to be talking about 3 points regarding this phenomenon. I'm going to start by briefly talking about why our model is getting so big. And mainly the gist of it is that deep learning technology, which stands at the basis of AI models, allows us to scale very, very well to large sizes and get accompanied improvement in our downstream performance. And then I'm going to talk about the negative side effects of this trend. I'm going to talk about several aspects that makes me concerned when models are becoming so big and so expensive. One point is about inclusiveness and who gets to use these models, and the second is about adoption and who gets to, the first is about inclusive and who gets to develop these models, and the second is about adoption, who gets to use the technology, and third, maybe most related to this conference, is about the environmental concern that arises from this trend. And finally, I'm going to present a few solutions or a few ways forward to mitigate the side effects, mainly talking about enhanced reporting of computational budgets and increased focus on efficiency rather than just accuracy. So let's begin. So why are models becoming so big? I mean, we've seen machine learning has been around for several decades, and we have in the first few generations of machine learning, we haven't seen this tremendous growth that I've been talking about ever since deep learning came around. And what's special about deep learning that allows us to grow so well? And the key idea is that deep learning models scale very, very well, and a very simple recipe to get a better model is typically to make it bigger. So let's look at an illustration. And when we think about deep learning models, we typically think of a large body that has lots of numbers. Typically, you can think of it as a large matrix. That's a very simple way to think about it, but it captures much of the gist of it. And the deep learning models is a mathematical function that performs a series of matrix multiplication. Now, in order to create a deep learning model, we also need data. We need basically lots of documents. In the case of text, we need lots of documents. In the case of images, we need lots of images. And these documents are typically labeled. So we have, for instance, in the case of the machine translation, we have pairs of the English and French documents, the English sentence or document and the corresponding French document. And then when we combine these two together, we get something that we call a trained model. This is the model that we consider an AI tool, and this model can perform inference on new unseen examples. For instance, in the translation case, we can take a new English sentence and translate it that we haven't seen before and translate it to French. Now, this is the basics of deep learning models, but deep learning models are interesting because they allow us to scale. We can take, for instance, a model and make it bigger by just using, for instance, larger matrices or more of these matrices. If our baseline model has, say, 1,000 or 10,000 parameters, we can just take 100,000 or 1,000,000 or 100 million, and these are not made-up numbers. We've seen models becoming so big that they contain even trillions of parameters or of these numbers. And we can also use more of them. Instead of multiplying 2 matrices or 5 matrices, we can multiply 10 or 100 or 1,000 matrices. And again, the key observation is that this technology allows us to scale very well, because when we're doing this, we're getting a model that is typically more accurate. And similarly to using bigger models, we can also use larger amounts of data. We can take our model that's typically trained on these labeled examples and just use more of them. Use basically, again, taking more and more labeled examples. And this will result in a model that's overall larger. And again, on the one hand, this is a typically more accurate model, a model that has more parameters, that is trained on more data. It will typically do better on our downstream tasks. But this model is also much more expensive, obviously, because each of these operations that we do requires some amount of energy, some amount of computation, which translates to more money, more energy, and so on and so forth. And obviously, the more data we have, the more times we need to perform these operations. And so growth in these 2 dimensions leads to higher costs. Again, the end result is that we have models that are becoming bigger and more expensive. Now let's talk about the side effects of this trend. So we've seen the benefits of it. We've discussed that the models are becoming more accurate and we're able to solve more tasks. But now let's talk about the other side of it. And first, the first thing to notice is that this creates problems of inclusiveness. Excuse me. We see models that are so expensive to generate. We have models in the millions of dollars or tens of millions of dollars just to train a single model. And this creates a serious challenge for people like myself in academia that can't afford to spend millions of dollars just to train a single model. And like myself, I'm assuming many other academics or people from small companies can't afford to train these models, which pushes everybody, almost everybody out, and leaves inside only the very, very big, very rich organizations, typically large tech companies that can't afford to spend these amounts of money. And this creates the problem of this raises the question of who's playing this game, quote unquote, of getting state-of-the-art results. But more seriously, who gets to decide what are the important problems that we're working on? On which data are we training our models? What are we leaving out and not necessarily researching? And these questions I think are very important and kind of in the basis of science, that we want science to be distributed and that many people can ask different scientific questions. And this is becoming harder and harder to do in the current climate. And the second problem that we can think of is a problem of adoption. And here the question is that given that we're building bigger and bigger models, that it takes, again, I've talked about examples that we've seen models that have hundreds of billions or even trillions of these parameters. These things can't fit on this phone or on your laptops. They typically require large servers to even run, and kind of the question arises: are we building this for our own amusement, or is the technology actually useful for real-world application? And finally, again, most related to these conferences, we are seeing problems with regard to the environment. And this is a paper that came out 2 years ago from a group at the University of Massachusetts that tried to estimate the amount of carbon that has been emitted by training state-of-the-art NLP model and natural language processing, and compared it to other things like transatlantic flight or the amount of fuel that is required to drive a car for a full year or for a lifetime. And what they found is that the most expensive models that we had at the time, again, more than 2 years ago, omitted the same amount of carbon as 5 cars would in the course of their lifetime. Again, given that we're seeing an exponential growth of the amount of energy required to train these models every year, we can only imagine that the current numbers are much higher nowadays. So to say a little bit more about AI and the environment, so the evidence that we have been starting to peak ever since that paper was published, typically talk about the most expensive experiment. Those, again, that cost millions of dollars, that's only the very large organizations can afford to run. And kind of maybe the counter argument for many of these organizations that these experiments, while potentially having a high carbon impact, are only typically run very few times because they are so expensive. And kind of the natural question that one can ask is, what about normal experiments? Experiments that do not take as much money, as much energy, and accordingly are much cheaper, but they are run many more times. There maybe are run hundreds or thousands of times a day in different labs across the world. And finally, perhaps the most influential factor is inference operation. Basically, taking a model that has already been trained, maybe the expensive part is over, and now we want to use it. This is a very, very cheap operation compared to training, but this is potentially something that's run billions of times a day. If you think of an AI system like Google search that currently runs a state-of-the-art AI model, or your recommendation system on Amazon, or your video service, editing service on TikTok, or any other application that has millions and billions of users per day, and they are all running small AI systems. And indeed, current estimates talk about between 80 and 90% of AI computation being spent on inference. So perhaps the key question to ask is, how do we measure these things, and how do we find a true estimate of the carbon footprint of AI? And with this thing in mind, we, myself and colleagues at the Allen Institute for AI, published an opinion piece last year, which we called Green AI. In this opinion piece, we talked about we call this trend that I've just presented a red AI, and talked about the problems of models getting bigger and the challenges that I illustrated. And then we presented an alternative to red AI, which we called green AI, where we talked about two main ways forward, ways to mitigate some of these concerns. One is to do enhanced reporting of computational budgets. Basically, we want to advocate for adding a price tag to scientific results. And it's something that can say, okay, I've published a paper and I have a new model that does this and that. And this is how much it costs to create this model, this is how much it costs to use it, and so on and so forth. And the second point is to promote efficiency of the core evaluation for AI. And this is not to replace the current practice of reporting accuracy, basically how good is my model at translating it, identifying object and image, and so on, but also how fast it is, how much energy does it consume, how much money does it take to run it, to train it, and so on and so forth. So let's dive a little bit about, very briefly, into these two topics. First of all, when we talk about enhanced reporting, here's one way to talk about it. Typically, what is being done in AI papers is that we see people taking their most expensive model and giving the accuracy level of that model. And what we're proposing is not just to report the most expensive setup, but also other setups that require a smaller budget. So here we're seeing an example, and we have a comparison between two models. On the y-axis, we see the accuracy, basically how good this model is at the given task. And on the x-axis, we see the company budget. How much does it cost to generate this model? And we see that, interestingly, in this example, we have two models. One that performs better on the left-hand side when you have a smaller budget, and one that performs better when you have a higher budget. So we believe this is a very important aspect of our models in order to make them useful in practice and in order to encourage the community to develop more efficient variants. And we want people to do a better job reporting their computational budgets and how much would it cost and how much would you gain from using a model that's more expensive or cheaper. And the second point that I want to emphasize is to put more emphasis on efficiency. And what you see here is an illustration of three main AI conferences from the past few years. And on the right, you see we sampled 20 papers from each of these conferences, and we examined manually whether their main contribution was a new improvement on accuracy, a new improvement on efficiency, let's say a model that is faster or that takes takes less space, and so on, or both or other. And we see that in all conferences, the main focus is on accuracy. And we believe this graph should be more balanced. We want to see more papers caring about efficiency, and we believe this is a way forward to mitigate some of these concerns. So what's happened ever since we published this paper? We got some very encouraging feedback. First of all, in some of the research results, I will describe some of my own research results, but many others have contributed very interesting research findings. My work, we've able to present better methods for comparing between different models that allows us to give a more accurate comparison that tells us how much computation does each model require. We've seen, I presented methods to make better usage of our data, to require less data. As I mentioned earlier, we saw that data is one of the key factors that makes models more expensive. And I also presented more efficient mathematical models, basically models that reach roughly the same accuracy, but you're doing so with far fewer computations. But we've seen also a large adoption by the AI community towards these ideas. We've seen special tracks and major AI conferences that focused on efficiency or green aspects. We've seen dedicated workshops that target issues of efficiency and sustainability. And we've seen efforts towards making conference submissions more reproducible, basically enhancing the reporting of computational budgets. And also very interesting was the feedback that we got from the broader community, from general public. We've seen a lot of adoption, a lot of the coverage in various news and media sources of these ideas. And I think this is extremely important in order to raise the awareness of these issues and try to push the community from the outside towards more sustainable practices. And indeed, with or without relation to these efforts, maybe one of the most impressive result of this is that we've seen the large players in our community starting to pay attention. So what we're seeing here on the top is a paper published by Google Research that came out just a few weeks or maybe a couple of months back that tries to estimate the carbon emissions of large neural network training. And also similarly, OpenAI, one of the largest AI organizations supported by Microsoft, also in their most recent large model result had a section about the energy usage of their published method. And this is, we would like to see more of these works, more of the big players and the small players starting to pay attention, starting to quantify how much carbon, how much energy is being required to generate this given architecture. Okay, so to conclude, we talked about why our model is becoming so big. We talked about basically deep learning, that's technology that allows us to scale very well to larger matrices and to larger amounts of data. And we've talked about the negative side effects of this trend, talking about inclusiveness, talking about adoption, and talking about the environment. And we presented two ways to potentially mitigate some of these side effects by doing enhanced reporting on the one hand and a larger focus on efficiency on the other. So with that, I want to thank you, and I'm happy to take questions.
Yeah, thank you very much for this illuminating and insightful talk. So it's a very nice follow-up talk to the last one that also spells out in a little more detail how your findings translate into policy recommendations, and it also ties in well with a sort of theme recurring throughout the conference. For example, using technology to manage the bad consequences of technology. So, and here my question would be, how do we make AI more green, more sustainable? So what do you think are the biggest challenges to that? So you pointed out some, but what would you think is the main obstacle we need to get out of the way to produce greener AI?
That's a great question. I mean, I'm spending time thinking about this on a daily basis, I must say. So I think there are several challenges that are, I mean, it's hard to say which of them are more important. I mean, if you care more about the inclusiveness and making this field of AI more sustainable towards the AI community, you want to take training models and make it substantially cheaper, driving it several orders of magnitude lower in order to allow more people to contribute. And that will be definitely one way that currently lots of people are thinking about it, but there's still a long way to go on that end. And if you care more about the environment, the focus definitely also should be on making inference more efficient. Again, thinking about the things that are run perhaps each individual piece is relatively cheap, but if you run it billions or trillions of times a day, you get something that has a huge environmental cost. And just reducing this relatively cheap operation by 10% could have a huge impact on the amount of energy it requires. So kind of these are the two endpoints that are, sometimes they're at odds, sometimes, you can train a model much longer, but get a model that runs at inference time much faster. And sometimes there's a synergy in between to making both training and inference more efficient. And this is a very exciting line of research that I'm actively involved in.
Okay, I have another question that touches upon one of the problems you mentioned, the problem of inclusiveness. So how do we select the different projects powered by AI? For example, I have here there's this one question. So in its recent cover story, The Economist identifies investment shortfalls as the main obstacle to staying on track for net zero by 2050. So investment shortfall in turn is mainly due to very long approval times for green projects. Now AI may help here with speeding things up by selecting more efficiently the most promising projects. But given AI's carbon footprint, this may have downsides. What do you think about such a use of AI?
It's funny. I think that this is often the case that this is a very multidimensional problem we're trying to optimize here. You don't want to, throw away the bathwater with the baby, trying to use AI to make something else more efficient, but at the same time, AI is taking more. You're spending more energy than what you've saved to begin with, and at the same time, I agree AI has tons of potential to help other fields become more efficient and more sustainable. And I don't think there's a clear answer here. I think we should all be thinking about. The fact that why do I think inclusiveness is so important and diversity is so important? Because it's very important for some people to think about some aspects and for others to think about others. And some people will develop a very important tool to help reduce the cost of other technologies, and others will make the tools themselves more efficient. So I think this is a great example of why we should be thinking more towards diversity and inclusiveness. I hope that kind of answers your
thank you very much for this nice answer. So I have another question from the audience. So seeing as you have been in this space for so long, as one of the pioneers, are you optimistic that people are more concerned with this topic, or do you have doubts?
So I'm generally I'm an optimistic person that might shadow some of my responses, but I'm very optimistic. I think people care about these topics. Especially I'm working in an environment of scientists, and basically my audience is my fellow scientists, and there isn't much climate change denial going around. So everybody is trying to do the best they can, and I think that people are open to hearing about these ideas, and even open to making substantial changes in the way that they work. And just to give you a small example, I mentioned that we're seeing new tracks in the main conferences. The tracks are basically places where you can submit dedicated work. So for instance, 2 years ago, if I had a work about efficiency, it wasn't a really good fit in any of the conferences submitted. I had to submit it into a general theme track. And now there are dedicated tracks towards efficiency and towards green. And the funny thing is that we initiated these tracks last year, and we've had them in several conferences, and we've seen a relatively low number of submissions. To these tracks, maybe 20 or 30 submissions in a conference of thousands of papers. And in the most recent conference that just the submission was a few weeks ago, we saw a jump from 20-30 to 150 papers. So I mean, almost 5 or 10 times more submissions, which kind of makes me think that it needs to mature a bit, and kind of people need to kind of think about it and start developing ideas. And maybe we're trying to see. I mean, I was very excited to hear these results. I mean, a lot more people are thinking about these problems, are presenting solutions, and I think that this is the way forward.
Okay, I think we have time for another question from the audience. This is sort of a follow-up, ties in perfectly. So you talked about the driving forces about changing the landscape, raising awareness. And who do you think is or should be responsible for leading this change? So should these changes come from companies, or should this come from practitioners making machine learning algorithms, or should policy makers take the lead? So who do you think should be driving this?
Yeah, you're asking great questions that I mean, there's no good answer for. I mean, I can tell you, I'm doing a lot to make these changes. I'm active in various. I mean, talking here is one of the things that I'm doing to promote this topic, and kind of working within the leadership of my community and trying to make these ideas more prominent is one way. The big companies obviously are the ones spending most, or at least doing the most expensive experiment, also have their roles. And as I've presented briefly, they're starting to notice, and maybe somewhat thanks to our efforts. And obviously, the public pressure also has lots of, I mean, for big companies that only see the revenue line in their work, doing public or regulation pressure will make them see beyond their revenue line, or seeing how making their technology more efficient will help them increase their revenue. So, I mean, there's so many ways to tackle it, and I think everyone can pitch in and do what they can. I don't think it's definitely not restricted to one person or one body of person.
Thank you very much. So the questions are still piling up in from the audience. Unfortunately, we have no time left. But thank you so much again for your exciting talk, your insightful answers in the Q&A, and we are very happy and thankful to have you here at this conference. But I must keep track of the schedule, so I need to move on to our next speaker. Thanks again.
Thank you. Feel free to email me if you have any follow-up questions. I'm happy to take questions offline. And thank you so much. Thank you.
So our next speaker, we are already 1 minute over time. I hope that's fine, but let's not waste any more minutes. So you have your full 20 minutes presentation and 10 minutes Q&A afterwards. So I'm happy to introduce Iakovina Kindylidi and Tiago Sérgio Cabral, and the floor is yours.
Thank you, Marius. Hello, it's great being part of this wonderful initiative. And both me and Tiago would like to thank you for the very interesting session so far, and give a special thanks to Amy, Larissa, and Jamila for the amazing organization and for giving us the opportunity to present our paper today. So my name is Iakovina Kindylidi. I'm a lawyer. I work as an international advisor in BDA, a law firm in Lisbon, and I'm a PhD student in the Nova School of Law here in Portugal. Together with my friend and colleague Tiago Sérgio Cabral, associate in BDA and PhD candidate in the University of Minho, we will briefly present some of the legal and policy challenges of sustainable AI, with a particular focus on consumer protection. So for the purpose of the presentation, to set a bit the floor, when we refer to sustainable AI, we refer to sustainability of AI, taking into consideration the entire life cycle, from training to implementation and use, as well as the 3 pillars of sustainable development with a focus on its environmental sustainability. Our presentation is divided in 2 parts. The first is a short policy and regulatory overview, and the second half is dedicated to a series of regulatory and policy recommendations that may help bring us closer to sustainable AI. In both parts, we will follow a horizontal approach, not focusing on sector-specific rules and policies, which may already address sustainability, at least to some extent, or that need specific requirements for sustainable AI to materialize. Luckily, over the past days, and especially yesterday, we had the opportunity to listen to experts addressing specific applications of sustainable AI, such as in health or in defense. As you know, and you have certainly understood from the discussion so far, the majority of the literature, private and public policies, have been focusing on how AI can promote the sustainability goals, or in other words, are referring to AI for sustainability and not sustainability of AI. And we can agree almost in hindsight that in order to achieve AI sustainability, some tools, at least from a policy perspective, are necessary to promote the development and use of sustainable AI. Therefore, in this part, we will try to map some of the current policies and regulations that refer to or may help to promote sustainability of AI. And we have divided it in two blocks, although we will see separately the proposal of the regulation for AI. So the first block are policies and initiatives around AI or the digital market. And secondly, consumer protection related laws and policies. But let's start from the first block and the ethics guidelines for trustworthy AI. So in the ethics guidelines, one of the 7 requirements that should be met in order for trustworthy AI components and the ethical principles to materialize is environmental and societal well-being. The requirements suggest that the sustainability of AI systems should be ensured and promoted throughout the AI value chain and the life cycle. You should note at this point that to the merit of the guidelines, that the sustainability requirement refers both to sustainability of AI and AI for sustainability, as it also addresses specifically the SDGs. To determine whether the AI product or service is sustainable, the high-level group suggests a critical assessment of resources and energy consumption during training. In the assessment list of trustworthy AI that was later published, this translates to a series of questions that seem to extend to the entire life cycle, so going beyond the training. And the developer should ask, are there any potential negative impacts on the environment from the use of the AI system or from its training? Which are they? Have we established any mechanisms to evaluate and mitigate the environmental impact? Of course, examples of the possible methodology that can be used or the mechanisms that can be used to assess the environmental impact or to mitigate it are not provided in the guidelines or in the assessment checklist. Considering that the list and the guidelines are also a non-binding tool, their application and enforceability is limited. Nonetheless, they have been providing some guidance to the various stakeholders involved in the AI value chain in the absence of specific regulation. That requirement was also picked up by the Commission almost a year later after the publication of the guidelines on the AI white paper. So the Commission sort of repeated the environmental requirement, and it also mentioned the impact of AI training on the environment, showcasing that the European regulator is aware of the environmental shortcomings of the process. On the same day that the white paper was published, also the communication for shaping Europe's digital future was issued, which aims in promoting an open, democratic, and sustainable society. One of the goals of the action is actually to reduce carbon emissions in the digital sector. The objective, of course, will have an impact on the AI development, considering that one of the key upcoming initiatives is achieving high energy efficient and sustainable data centers by 2030. But let's move on to the second block and to consumer protection.
Currently, there are no specific rules regarding the substantiation of environmental claims. We have one available tool that comes from the Directive on Unfair Commercial Practices, which prohibits any claims that are found to be misleading to the consumer. However, it does not contain any specific rules on environmental claims. Nonetheless, in general, under the Unfair Commercial Practices Directive, a commercial claim is not misleading if it is presented in a clear, specific, and ambiguous and accurate manner. And the traders need to have scientific evidence to back their claims. For AI, this would mean, for example, that it would not be possible to advertise a certain AI as being trained 100% on renewable energy if that was not true, or if there was no manner to ensure that was indeed the case, the use of renewable energy. Of course, these criteria should be assessed on a case-by-case basis, considering that the transposition and enforcement levels of the directive vary amongst member states. Its application to, and due to this, its application to greenwashing practices is limited and fragmented across the EU. Still, it is important to go one step further and to understand if there is a margin in the current legislation to argue that in certain cases, there can be a proactive requirement to offer sustainability-related information for AI-based products and services. On this point, both the Consumer Rights Directive and the Unfair Air Trade Practices Directive are clear in establishing that the consumer should be informed about the main characteristics of the goods or services to the extent appropriate to the medium and to the goods and services themselves. Of course, the obligation should be interpreted in a coherent manner between both instruments. So we have a question now, which is, can sustainability-related information, environmental-related information fall in the main characteristics of AI? This question is particularly interesting in this field because, as we have seen, AI can be both an engine for sustainability, but also a drain on natural resources. And consumers may want to know in which category does their specific AI or the AI they are buying falls before completing their transaction. And as we have seen before, for AI to be trustworthy, it has to be both transparent and sustainable. Well, to answer the question that we posed, there is no clear legally binding requirement to provide sustainability-related information specifically for AI products and services. While it's certainly true that consumers are aware of sustainability in general, it would be relevant to know if they value it more when it relates to AI comparing to other characteristics of the product and service, to understand if it should be considered a main characteristic. For instance, in an autonomous vehicle, if we have an AI technology that can reduce fuel or electricity consumption in 40% due to its advanced workings, one can argue that this is important information and may even be a main characteristic of the product, and therefore the consumer should be informed about it. On the opposite side, the fact that gaming console A consumes 5% less electricity than its main competitor, it's probably not the first thing that consumers are looking at. Well, in our slides, we have included the Eco Design Directive, as its objective is to provide easily accessible and uniform information to consumers. The directive has a broad definition of energy-related products, and it covers a product that has AI embedded, as long as they have an impact on energy consumption during their use. However, it does not cover the training of the AI itself, that, as we saw before, can have even greater impacts. And it will end up being applicable mostly to devices that only function limited in an autonomous way, such as robot vacuums, and that in theory are AI, but they are not as smart, and their design and training has limited environmental impact in comparison to advanced AI systems with using machine or deep learning. The Eco Design Directive will be updated by the Sustainable Products Directive, announced in the Circular Economy Action Plan. And it is supposed to extend the scope of the directive to also cover ICT products. But we are not expecting that will cover AI, since AI is not currently contemplated in the Circular Economy Action Plan. At the end of the last year, the European Commission published the new consumer agenda. The agenda outlines the EU consumer policy vision until 2025, and it's based on 5 strategic areas: the green transition, the digital transformation, redress and enforcement of consumer rights, specific needs of certain consumer groups, and international cooperation. As it is understood from the context of each strategy, the agenda is following an holistic approach, addressing various existing consumer protection policies or the consumer protection aspects of other initiatives of the European Commission. as for instance, the EU digital strategy aiming to align their objectives, and it's aiming to align their objectives in order to enhance information transparency among stakeholders, empowering consumers, and ultimately cleaning the house from a legal standpoint, making things simpler. But the problem still persists. And as greenwashing practices increase across industries, especially in relation to digital products and services, one of the initiatives announced and expected by July is the proposal for regulation for the substantiation of sustainability claims. This solves a part, because it solves the part where currently there is no standard or universal standard for making green-related claims, sustainability-related claims. However, it does not solve the other part, which is that there is no legal obligation to proactively provide this information. You just do it if you want, and if you do it, you will have to follow certain rules. On the 21st of April of this year, the European Commission finally presented its proposal for regulation on the European approach for artificial intelligence, known as the AI Act, putting forward a single set of rules to regulate artificial intelligence in the European Union. The proposal opts for a risk-based approach to AI regulation, with most of its obligations being reserved for what is called as high-risk AI. And we have to admit, it does possess the makings of a very effective legal instrument. It contains detailed rules on market surveillance. It contains very high fines. Its application is very broad. And with this, based on these characteristics as a legal instrument, the proposal could be designed in a manner that could contribute to further promoting transparency and sustainability and reinforcing consumer protection, information transparency, and enforceability of the rights related to these matters. However, surprisingly, sustainability is mostly ignored in the proposal, with the exception of the possible integration of requirements related to environmental sustainability in voluntary codes of conduct, which are voluntary. You do not have to apply them. If you want to create one and put there sustainability-related information, you can, but it's not mandatory again. In a proposal that establishes requirements that go from risk management to data governance, and where transparency actually takes a central role, one cannot avoid thinking that it would be easier to go further. And in fact, it would be logic in the context of the proposal. At least for high-risk systems we could establish an obligation to detail sustainability impacts in the context of the technical documentation that it's already mandatory to draft, and then just create a second obligation to disclose said impacts to the consumer. This procedure would not be difficult. And there's one second thing that we have to address here. Notwithstanding the type of regulation, either if it's detailed rules or a more light principle-based approach, it's important to have sustainability rules on the regulation, because it will mean that the European Union's fundamental rights standard will be applicable, and the likelihood of action by the Court of Justice of the European Union raises higher, and the Court of Justice is very active, and this can be a good thing for sustainability and for the defense of sustainability.
So we've already mentioned at the beginning of our presentation that comprehensive tools from a policy perspective are necessary to promote the development and use of sustainable AI. As it was understood from the previous analysis, such tools do not exist at the moment. Therefore, we need to start from the basics, and sustainability of AI should firstly be addressed. This ideally will happen in AI law. Hopefully, in the final text of the AI regulations, since the mere mention of sustainability in voluntary codes of conduct is not sufficient, and it will lead to a limited and fragmented adoption. Alternatively, AI sustainability can be addressed in a consumer and environmental sustainability framework. For instance, the Sustainable Products Initiative, or in the substantiation of sustainability claims, although this is not very likely. At the same time, courts may assist in addressing whether sustainability is an essential characteristic of certain AI products and services to determine whether sustainability information should be provided to consumers. Considering, however, that the EU case law is rather limited in this area, a case on sustainability of AI at the moment, it seems very far away. Furthermore, sustainability of AI can be addressed in guidelines and generally accepted codes of conduct, which brings us to the next 3 recommendations. Information sharing and collaboration to ensure the best practices of the industry, the development and adoption of technical tools, and I will add, following Roy's presentation, also to surpass the difficulties created by costs are necessary. From a consumer protection and sustainability claim standpoint, although the obligation to provide the information to the consumer lies with the product manufacturer and trader, a transparent and facilitated flow of information between the stakeholders of the AI value chain is essential to ensure substantiation of such claims, especially when the provider is not the same as the designer. In this case, it's advised that information regarding the sustainable features of the product are addressed and support after they are put on the market is given to the trader, for instance, in order to meet their own consumer law obligations. Such practice can be enforced contractually, but such contractual enforcement, although it helps the trader prove that information was provided to the consumer, it presupposes a formal contractual relationship with a contract negotiation and a certain level of market power, something that in a field where there are several researchers and SMEs, the application of this measure might be limited. Of course, to see results and to have an impact in the industry, large-scale adoption of solutions is needed. For this reason, any sustainability monitoring tools should be interoperable with various AI systems and applications, while at the same time, interoperable AI models should be promoted more. This also extends to interoperable, secure, and reusable datasets, something that EU Data Spaces initiative is aiming for, but we will see in practice how it will work. From a digital public services perspective, although not expressly referring to AI applications, the principles of EU interoperability framework, including the principle of reusability, should apply to AI-powered digital public services. From a business perspective, to achieve interoperability and reusability, interoperable standards should be developed together with a clear set of criteria in order to assess when an AI is sustainable. I will not dive more into a clear labeling system and the need for it as it was addressed yesterday, but from a consumer protection perspective, there is a need for an aligned and harmonized labeling system in the EU, which means that the current system should be updated. To conclude, and provided that the previous steps have been taken both by policymakers and industry, a proportionality framework, something that was also proposed by Amy, to assess at EU level whether the environmental impact related to the training and use of AI and whether certain applications are proportionate should be developed. However, we believe that such framework should be objective and detached from the particular application of AI, especially in the training phase of its life cycle. Of course, at the use stage, it is reasonable that different levels of energy consumption can be justified. For instance, a healthcare AI used in a hospital is expected to function for more hours and therefore to consume more energy and have a more significant carbon footprint. Alternatively, provided the proportionality principle in relation to sustainability of AI is in fact included in the final text for the AI regulation, a link can be introduced between limiting not only the use, but also the development of forbidden AI systems, such as AI for social scoring, to avoid the increased environmental costs, and demand that high-risk AI systems are environmentally sustainable throughout their life cycle. Considering the stage of the technology and the level of the discussion, which of course, and this conference has contributed significantly at, the first option may be more realistic. Thank you very much, and we are open also to more questions. You can contact us. Here are our contact details. And I also had a Q&A image, but I think it's better to look at Marius instead of that. Thank you very much.
Thank you very much for this extremely rich talk. I think that there's a lot to unpack here, but unfortunately we have not that much time. So let's see if we can focus on the more big picture question. So I have the first question is similar to one that popped up in the last Q&A, and so I want to take it up. Because there's this a theme in the last talks or a topic between the relation between your findings, your analysis, how that should translate into concrete action, given all these vague policies and guidelines, and you went a long way to fleshing out like concrete policy recommendations. So the question is, what is where do you see the biggest challenges in this relation between your findings and how to put that into action? So this is similar to the question: who should drive the change? Should we where should we start? Like more guidelines for companies? Should we encourage consumers? Where do you think is the best way to start, given the difficulties and obstacles we are facing?
Thank you. It's a complicated question, and if only there was one silver bullet that we could use to solve this. I think the problem in general starts from information asymmetry. So there are always delays, and the regulator does not possess sufficient information for the technology. At the same time, the technology is moving gradually, and we have a lot of advances, but something that the regulator might know today might not be relevant tomorrow. In relation to sustainable AI, this is even more important, because from a policy perspective, we see even on academia, a lot of papers on AI for sustainability. So for many years, it has been overlooked, sustainability of AI. It was more a focus on blockchain technology rather than on AI technology, because it was so evident. So I think one first important step is exactly this communication. It already happened when it comes to AI with the high-level group. So I think that's the first step. And now the discussions are taking place regarding the regulation. There needs to be more push from the industry, from the academia, in a multidisciplinary level, to include in a more clear way the obligation for sustainable AI in the regulation, because as also Tiago mentioned, is practically overlooked. It's an option, and it shouldn't be an option.
Mm-hmm. Thank you very much. This is a great answer. So this is a nice follow-up question I got from the audience, given the global dimension of the topic of AI and the sustainability of AI. So here's the question: do you think all countries should use the same framework, or should there be differences depending on how mature the country is when it comes to their AI and data center infrastructures? So should we? Yeah.
I don't know if Tiago wants to take it, because it has to do with the extraterritorial scope of the proposal.
I can take it. The ideal situation would be indeed for an harmonized set of rules that would be as wide as possible. So if the whole world wanted to sign below, it would be great, but it's impossible, or it's very difficult from what are the limitations of international law. Countries have different sets of rules, different ways to see democracy, different ways to see the development of AI. And if you see the European approach, it's not compatible with the approach of other non-democratic countries. For example, the proposal on the regulation of AI is very focused on fundamental rights. And then we'd have a trade-off. Do we want a minimum set of rules which can be agreed by everyone, but which in fact are not enough to protect the consumer, or the protection of the consumer would be very low? Or do we prefer to go by blocks and to have higher standard? And on that, I personally prefer to have a higher standard. So within the higher standard and the block, we have to find a coalition of like-minded countries that would be available to establish some rules, or some rules that offer a decent, adequate level of protection with the European Union in this case. So the thing will go like this: the European Union is already on it. it will be the first to finish it, and we'll have an European framework. I think that will be approved by the end of this year and applicable 2 years after, so 2023. And then we start the entire procedure to find the allies, so the like-minded countries. A great option would be for the US and the European Union to agree on a specific set of rules, on a specific set of values, on a specific set of principles, because it would put our strategy, or a common strategy, would give it much more influence, much more clout internationally. But the question is, the answer is internationally, it would be great to have everyone on board. That will never happen. So let's go as far as we can, but do not sacrifice what is the values of your regulation.
Thank you very much, and I'm pretty sure the person putting up the question should be satisfied by this great answer. So we need to close a minute early because for tech prep for the next panel. But thank you so much to both of you for your great presentation. I'm sure there's a lot that is still to unpack, and well, people have your email addresses. Feel free to contact them and pose further questions. Get in contact. I will close here this session. Thanks to all speakers and contributors, to the audience and all the questions out there. Next up is the panel Thinking Beyond Today, Intergenerational Justice, Sustainability and AI, hosted by the World Economic Forum Global Future Council on AI for Humanity. Stay tuned, we are right back.